Hi friends, we are back again with another video, and this time we shall be looking at how you can write a Java program that will determine whether a number is a prime number or not. But before we continue, be sure to like and subscribe to the channel. Okay, so when trying to write a program that determines whether a number is a prime or not, there are a series of steps that we have to follow. The first step is to know what a prime number is. Like, you just don't want to dive into writing a program that determines a particular condition without really understanding the terms you are playing with here. Okay, so know what a prime number is. Okay, and then secondly, we have to know the conditions, okay, for a number to be a prime number. Okay, so what is a prime number? We know that a prime number will definitely be a number that will only have two factors, right? That is 1 and itself, but there is an exception for 1, isn't it? Yeah. And then secondly, we have to know the conditions for a number to be a prime number, and these conditions are: the number must be greater than 1. Okay, remember that 1 is an exception here, okay, because it is just 1 and itself. Okay, and then secondly, the number must only have two factors. So you are going to be looking at these two conditions. Okay, so firstly, we are going to test out the first condition. Okay, if the number passes the first condition, then we can go ahead and check for the second condition. All right, otherwise we don't have to move on if it fails the first condition. Okay, so let's see how we are going to turn that into code. Okay, so I'm going to create two variables. Okay, so the first one will store the number that we are testing out. Okay, and then the second variable is going to store the number of factors. Okay, yeah. And then let's say maybe let's try with let's start with a 3 this time. Like, we'll be testing out a 3. Okay, yes. And then, because we shall be frequently adding to the factors, let's initialize it with a 0. Don't worry, you will understand as we go on why we are initializing it with a 0. You will appreciate, definitely. Okay, so now here I've got this number. Okay, and then let me try to find out whether it is a prime number or not using the Java language. Okay, so I'll go ahead and test out the first condition, which is uh, if the number is greater than 1 or not. Okay, remember that if the number is greater than 1, yes, we can continue to the next condition. Otherwise, we know that it is not a prime number. Okay, so I'll start with the first if statement. Says if that number, okay, is greater than 1, okay, then we can continue with whatever code that will come in here, that is in testing out for the second condition. Okay, otherwise, once this first condition fails, let me say else, just print that not a prime number. Okay, but if this condition passes, then we can go ahead and check to make sure that we only have two factors. Okay, so now in trying to find out whether we only have two factors or more, let us try to divide, okay, into that number all the numbers that are less than that number. Okay, yeah, those that leave a remainder okay, will not be termed as factors. Okay, only those that will divide into the number without leaving a remainder will be called the factors. Okay, and we are going to do that with the help of loops, and I'll be using a for loop. Okay, so it's the for. I'm going to declare my counter I and set it equal to 1. Okay, and then the condition is making sure that my counter is less than or equal to the number. Okay, and then I want to be incrementing the counter. So basically this variable I, which is basically a counter, it will be representing all values that are less than this number. Okay, yes, and then let's see what we're going to do in the loop. Okay, so in this loop we are going to bring in a nested if statement. Nested if statement means an if statement within an if statement. Okay, like that. And then if the number divided by I, okay, by I, say is equal to 0. Okay, so this definitely means that if we divide I into number is equal to 0. Okay, so that means that we are trying to fetch the factors here. Okay, yes, so remember that I will be any number that is, or any value that will be less than this number. Okay, so let's say for instance we have 3 here. Okay, so the first trial, or the first number that will be stored in the counter is 1, right? So we shall have 3 divided by 1. Okay, if we have a remainder equal to 0, or basically if we won't have any remainder, okay, then there should be something to happen, which we are about to write here. Okay, and then the next value that will be held by I will be 2, right, since we have set this to be incrementing by 1. Okay, and the same operation will happen here. Okay, and then from there we'll have I as 3. Okay, so it will be when number divided by 3. Okay, what remainder are we going to have? Okay, remember that this modulus sign tries to give us a remainder. Okay, like if I say 4 modulus 2, I'm trying to find the remainder when 4 is divided by 2, isn't it? Yeah, I hope you understand. Okay, so when that number is divided by I gives us a remainder of 0, then we know that we can increment the number of factors by 1. Okay, like that. Okay, so this is the main reason as to why I initialize it with a 0, so that it becomes easy for us to add. Okay, otherwise if we didn't initialize it with 0, it would throw an error because you cannot add. Okay, like that. Okay, this gives an error. Okay, because there's nothing being stored there, so I must initialize it with a 0 so that I can add the 1 to have it 1, and then I add the other one, it increments to 2. Okay, just like that. So this will continue until until I reaches its limit, where it must reach the highest number being less than that number. I hope that makes sense. Okay. So this is basically what we want. Okay, and then now after that for loop, we are going to break out of the loop. Okay, and then the next thing that we want to do is to now check how many factors we have in the end. Okay, so say if factors is equal to 2, okay, then know that it is prime number, isn't it? This is a prime number. Sorry, prime number, right? Otherwise, we know that this is not a prime number. This is not prime number, like that. Okay. Yes. So let's just run through the code one last time. Okay. So we first test for the first condition. Okay, if that number is greater than 1, okay, we go on to test out the second condition. Okay, otherwise it will be automatically not a prime number. Okay, so when we are checking for the second condition, which is how many factors we have, okay, we first want to try and derive factors from that number, okay, that is by frequently dividing by numbers that are less than that given number. Okay, for example, if our test value was 10, that means that we are going to try to divide into it all the numbers that are less than 10, okay, so that we see which numbers leave a remainder, and those we cast them out as not part of the factors, and then those that don't leave a remainder, those are the ones that are factors, and this is what we did here. Okay, and then after that loop, we want to now check if the number of factors is equal to 2. Okay, if the number of factors is equal to 2, then we know it's a prime number. Otherwise, it will not be a prime number. So let's try to run the code and see if this works. Okay, remember we are testing 3. Let's see if 3 is a prime number. Okay, theoretically we know that 3 is a prime number. Let's see if the code will tell us the truth. Okay, number, run that. Okay, see, this is a prime number. Okay, what if I hit it with the 4? And that this is not a prime number. See, it works. Let's say 9. Okay, so that 9 is not a prime number. Why? It is because it has more than 2 factors. It has got 9, 3, and 1. Okay, so it does got 3 factors, so that means it's not a prime number. So that's it, guys. Thank you for watching. Be sure to subscribe and click on the like button and also the bell icon to make sure that you don't miss out any of our next uploads. So thank you guys for watching. Have a blessed day.